Dear all, good evening. Today, let us see the important topic, that is how to solve problems by using elimination approach. Elimination approach for the one-dimensional bar element problems. If you know this concept, this is one-page report. If you know this concept, you can solve any type of problem from the one-dimensional bar element from the FEM unit number 2. Okay, very easy concept. Okay, so you have to know some basic concept, some basic formulas. Here kq is equal to f. This is a very important formula. Entire FEM you can use the same formula. So here k is equal to global stiffness matrix and q is the global displacement vector, where f is the global load vector. As you know, f load, q some displacement, and k is the stiffness. Okay, so in the most of the problems they will ask about to find out the displacement and stress and reaction. Okay, we will see. So in this, where k is the global stiffness matrix and k is the element stiffness matrix. Okay, as you know, there are so many elements in this. Here, for example, if you observe this figure, let us take this figure. This is the bar element, this is the element 1, and this is the element 2. So you can divide into number of nodes. This is the node number 1, node number 2, and node number 3. So here we have lengths L1 and L2. So in general, in the problem they will give the L1 and L2. Here they are given the P, some load. So this is at node 2. So you can take this P as P2. Okay. So here Ke Ae by Le 1 minus 1 minus 1 1. Suppose if you take per element 1, you can write as, in place of E you can write 1. Per element 2 you can write 2. If the more number of elements are there, then for K3 you can write A3, E3, L3. So like that we can take this elemental formula, where K is the element stiffness matrix, A is the elemental area, and L is the length, and here E is the Young's modulus. As you know, Young's modulus stress by strain, sigma by epsilon. Okay, here you can use any notation. So here there are two elements, so you can write K is equal to K1 plus K2. If one more element is there, you can add K3, K4 like that. Okay, so from this example, to find out the capital K, that is the global stiffness matrix, you have to add all the elements. Those are K1 plus K2. So as you know, K1 formula A1 E1 L1 by 1 minus 1 minus 1 plus 1. Here area, Young's modulus, and length values will be given directly. So you can solve very easily with help of the calculator. Okay, so then you will get like this 10 power 8. Here you have to take out 10 power 8 or 10 power 6 like that. So by keeping the minimum values here, you have to take the maximum value out. So then 10 power 8 into plus 5.6 minus 5.6 minus 5.6 and 5.6 like that. Similarly, you have to find the K2 value with this formula. Okay, then you will get the K1. This is K1 and this is K2. Okay, after getting this, you have to find the capital K, that is global stiffness matrix. Here node 1, node 2, node 3. So you have to write first 1, 2, 3 and 1, 2, 3. You have to write empty matrix. After then you have to keep this values. Here 10 power 8 you have to take the common. So you have to add this 2 matrix, 1, 2, 1, 2. This is 2, 3, 2, 3. So you have to write 1, 2, 3, 1, 2, 3. First empty matrix. Then you have to fill this one. Here see, this is 1 and this is 1. If you observe, see here 1 and 1. So 1 and 1. So this is 1, this is 1. So 5.6. So you can write 5.6. Then 2, 1. So 2 by 1. So here 2 and 1. So this is minus 5.6. Then 3, 1. 3, 1. So but here 3 is there, but there is no 1. So you can write 0 directly. Then 1, 2, 1, 2. So here 1 and 2. So 1, 2, the value is minus 5.6. then 2, 2, 2 by 2. Here 2 and 2, so this is 5.6, this is 5.6. Again here also 2 and 2, this is 3. So 2 by 2 is 2 times. So here 2 by 2 5.6, and here 2 by 2 3. So you have to add these 2 terms. Then next one 3 by 2, 3 by 2. So here 3, 2, so minus 3. Then 1, 3, 1 by 3. So here 1 is there, but there is no 3, so 0. Then 2, 3. So 2 by 3. See, here 2 is there, here 3. So 2 by 3 minus 3. Then 3, 3. So 3 and 3. So 3 and 3, this one 3. So like that you have to fill the global stiffness matrix. Then you have to simplify, or you can write all, but here you have to add 5 plus 3, 8.6. Okay, then K11, then you can write K11, K12, K13. First one 1 1 1 2 1 3, then 2 1 2 2 2 3, third one 3 1 3 2 3 3. You have to write the names like that. This is 3 by 3 matrix, so 3 rows and 3 columns. So then this is the K. From this formula here KQF, so you got the K value. Then after that you have to find the Q and F values. Here Q1, Q2, Q3, where F is F1, F2, F3. So here 1 2 3 3 nodes are there. So like that you can write, this is the 1 2 3 3 rows, only 1 column. Here also 3 rows, 1 column. So you can write like this. Here we observe this figure. Here 1 2 3, this is the 1 and 3, both are fixed supports, so there is no force. But here see, they are given some force, some load at second point. So you can take P2 or F2. You can take directly F2 is equal to P2 or F2 is equal to P. Okay, so like that. So here K is equal to 3 by 3 and Q 3 by 1. If you cancel 3 by 3, you will get 3 by 1, that is equal to F 3 by 1. Okay, so to solve this problem, we are having one is elimination approach method, other one is penalty approach to solve the one-dimensional bar element problems. Okay, here most important, most commonly given method is elimination approach. So if they ask specifically, you can use either elimination or penalty. If didn't mention, you can use any one method. So basically elimination method is more user friendly, so it is easy to solve the problems very easily with the help of elimination approach method. So here first of all you have to take the boundary conditions. So take displacements at fixed supports as 0. So at fixed supports, here 1 and 3 are fixed supports. So at this place the displacement value will be 0. So Q1 0 and Q3 0, right? Then remaining at second point only, you will get some displacement, that is Q2 only we will have some value. Then also here while doing the elimination approach, you have to cancel the rows and columns. You have to eliminate, you have to cancel all the rows and columns. Let us see here, that means 0 values, you have to corresponding 0 values, you have to cancel those rows and columns. So from this formula KQF, so this is K, this is K, this is capital K, this is K, and this is Q, and this is F. So KQ is equal to F. So in this formula, see, as I told earlier, all corresponding rows, that means at fixed supports, okay, you have to cancel the, you have to eliminate rows and columns. So here Q1 support 1, so Q1 means first row, first column you have to cancel. Again Q3 third row, third column. So like that you have to cancel the entire row and column. Then only 8.6 Q2 P2 will be there. Then you can write to 8.6 into Q2 is equal to P2. Okay, then you will get Q2 is equal to P2 by 8.6. Okay, so from this formula P2 will be given directly with some value in the question. They will give in that directly. So then you can solve directly Q2 value. Okay, similarly you have to solve the next value. In the problem they will ask to find out the stress value and find out the reaction force. So they will ask the reaction force also. These three values commonly asked in the exams. So here for the stress we need the this formula. As you know, as I told earlier, Young's modulus is equal to stress by strain. Stress by strain. I am using the same formula. So Young's modulus is equal to stress by strain. Now from this formula you can write stress sigma is equal to this one, Young's modulus into epsilon. So now you can write sigma 1 is equal to E into epsilon 1 and Et is equal to E into epsilon 2. Okay. Now there are one more formula. As you know, this is the strain. Okay, this is the strain. As you know, strain formula change in length by original length. Here per elemental 1, L1 is the original length and L2 is the original length. So here change in length means per element 1 in between 2 and 1, 2. So Q2 minus Q1. Here this is second element in between 3 and 2. So see here Q3 minus Q2. Here Q2 minus Q1. One is L1, other one is L2. So in the question you know already Q1 and Q2 values. So from that you will get Q1 and Q2 values, and in the question, in the problem they will mention L1 L2, so you can easily get the E2 and E1 values. Okay, by keeping here E1 and E2 values you will get the stress values, sigma 1 and sigma 2 values very easily, like that. Okay, next one, reaction force. Here at fixed supports only reaction force will be occur. Okay, here 1 and 3 are fixed supports, so here only we have the reaction force, right? So you have to take the formula K11, 12, 13, Q1, Q2, Q3. This is at node 1. Similarly, third node, node 1, node 3, K31, 32, 33. So here K31, 32, 33, Q1, Q2, Q3. We observe, as I told earlier, so here already Q1 value 0, Q3 value 0. So you can cancel Q1, here Q3, and here Q1, Q3. And also F1 and F3 also 0 loads. There is no load. Only they are given the P value or P2 value also they are given. So like that you have to cancel all the values. Then here you will have only K1T Q2 is equal to R1. So from this you can write simply R1 is equal to K1 to Q2. From this you can write R3 is equal to see simply K32 into Q2. Okay, now let us see the similar problem from that problem, how to solve easily. Okay, with the same concept you can solve the easily. See this problem carefully. Here see a cantilever bar shown in figure. This is the same similar one. An axial load of P. This is the P 210 cube newtons is applied as shown using the elimination approach. They are mentioned elimination approach by handling the boundary conditions to the following. Determine the nodal displacement, asking displacement. Determine the stress in each material, asking the stress sigma, and determine the reaction forces. So in this problem they are giving, this is one material aluminum, this is steel, element 1, element 2. This is load P. This is 300 mm, 400 mm. This is L1, this is L2. So they are given A1, EA2, and also E1, E2 values. Okay, here this is value is given in mm square, so you can convert into meter square. Okay, just simply multiply with 10 power minus 6. You will get the value directly in meter square. Okay, now from that problem, this is similar problem. Okay, so now as I told earlier, you have to first find out the K1 value, A1, E1 by L1. Similarly here E1 value, A1 value, L1 value we are taken directly from the given data. See E1 value 70 into 10 power minus 9. Then A1 value I have converted to meter square, 2400 into 10 power minus 6, 2400. Then L1 value, see here L1 is in 300 mm and 400 mm, but I was converted into meters, so 0.3 meters, here 0.4 meters. So I am writing like that. So 0.3. Similar here 0.4. A2 is equal to 600 and E2 is equal to 200. So E2 200 and A2 600. Okay, I was substitute here. Then I got K1 values and K2 values. So yeah, this is 10 power 7 56. This is 10 power 7 30. So here I was taking the 10 power 6, but here, as I told earlier, you can take out 10 power 8 also. Similar problem only. So then it will be 5.6 10 power 8. Okay, and 3 into 10 power 8. But here we observe, so 30 into 10 power 7. 56 10 power 7. You can write anyway. Okay, not issue. You can follow either this method or this one. So then you will get the K value, then F value, that is P1, P2, P3. As I informed earlier, you have to solve like a global matrix 1, 2, 3, 1, 2, 3. Here, see 56 10 power 7. 86, but here 8.6. Similar problem only I will take it. Then F1, that is P1, P2, P3. So they are given P2 value 200 into 10 cube. In the question only directly they are given P2 value. Okay, so you have only P2 value. Then KQ is equal to F. That is here already Q1, Q3 are 0. As I told earlier, Q1, Q3 are 0. Similar problem only I have taken. So Q1 0, Q3 0. Okay, so then you got like this. Then again you have to take the Elimination approach, K, Q, F. Here you can cancel first row, first column, third row, third column. Then you will have only 86 into Q2, this value. Here 10 power 7, but there 10 power 8 into 8.6, like that, not an issue. Then you will get the Q2 value. Okay, after solving Q2 value, then you have to find out the stress value, sigma 1, sigma 2. That means Young's modulus into E1, epsilon 1, E2, epsilon 2. So I already told you E into Q2 minus Q1 by L1. This is E2 into Q3 minus Q2 by L2. This is the formula. So this is for the stress formula, Young's modulus into E1. Here Young's modulus into E2. So you have E1 and E2 values, right? So then you have to find like this. You know already Q1 and here Q1 and Q3 are zeros. Only Q2 by L1, Q2 by L2. You know E1, E2. Then you will get like this. Okay. Then to find out the reaction forces, you can use the similar formula K11, K12, K13, F1, R1. Here K31, 32, 33. So here you can cancel all the values. You know Q10, Q30, Q10, Q30. Then here only you have Q12, here Q32. You know already. You know all the values here. See, this is the K12, this is the K12, and this is the K32. So then here you can take minus 5.6 into 10 power 8, or here minus 3 into 10 power 8, or otherwise you can here 56 to 10 power 7. You can use it for any, you can follow any method, no issue. So then you know already F1 and F3 zeros. Then you will get the R1 and R3 directly. Okay, these are the similar problem. Tomorrow you can see the some other problems. Okay, thank you.